Alright guys, this is 12.4 and what we're going to be doing today is talking about the volume of prisms and cylinders. Remember, volume is how much something can hold. So for instance, if you're looking at this top box here, how many cubic units could we stack inside of that box? And if you look closely at it, notice that you have a 5, you have a 5, and you have a 4. Well, if you wanted to figure out how many cubic units you could put in, you would simply go 5 times, right? It's going to go 5 this way, and then 4 stacks up, right? Well, essentially, the volume of a unit cube here, or how many unit cubes, this is not a cube by the way, a cube has all sides and edges the same, but this is a rectangular prism. So what you would do is you would simply multiply the length times the width times the height, and that's the easiest thing to do when you're talking about volume of a rectangular prism. You just multiply the length times the width times the height. So if I wanted to know how many number cubes will fit in the box, I would simply say 5 times 5 times 4, which is going to be 25 times 4, which would be 100 cubic units. So whenever you're talking about volume, your units are always cubed. As an example, if this were inches, it would be inches cubed. It's the same concept as area. Area is always squared. So, but that's why, is because you're multiplying 3 of the items here, the length times width times the height. Now, not every prism that we're going to be working with is a rectangular prism, and so I'm going to give you a formula for the volume that is going to allow you to find the volume of any figure. So the first one, or the formula, is volume is equal to the area of the base times the height. B is still going to be the area of the base, and H is going to be the height of the prism, or you could think about the height as the distance between the two bases. Okay. And I could draw any kind of prism. There's not a set prism, so if I'm looking down here, I would find the area of the base times the height, area of the base times the height. For a cylinder, remember now, a cylinder, we do have a diagram to draw for the cylinder. So it's the same exact formula, except the area of the base is one specific formula. The area of a circle is pi r squared. So the volume of a cylinder is pi r squared times your h. So those are your two formulas for the volume. So I just have, I think, 3 or 4 examples of that, and pretty much that's the gist of the lesson, is finding the volume. The hardest part about this is going to be finding the area of the base. Find the volume of the right prism and the cylinder. So the first thing I would do is say, okay, well, I notice that this is a right triangle. If you take a look down here at the bottom, you do see that right angle there. This is a right triangle prism, which means that our base is a right triangle. So this right here is my base, that right triangle. I know that this is 3 and this is 4. How do you find the area of a right triangle? Well, that's easy, right? The area of a triangle is 1/2 the base times the height. If it's a right angle, then this is your height, right? So it's going to be 1/2 of your base times your height, which is going to give you half of 12, which is going to give you 6, and that would be in terms of centimeters squared. So that would be the area, or capital B in this case, is going to be 6. Now remember, the height of the prism is the distance between the two bases. Well, that's going to be 2. And guess what? Volume is equal to the area of the base times the height. So the volume is equal to 6 times 2, which is going to give us 12 centimeters cubed, and there would be your volume. Once again, for a cylinder, you just need to know the radius and the height. So if I'm looking here, I see the radius is 3, I see the height is 10.2. So pretty easy, you're just going to plug it in. So pi r squared h, pi times 3 squared times 10.2. and that's going to give me 9 times 10.2. 2 is 18, carry the 1, 91.8 pi, and that would be in terms of feet cubed. So if you wanted to multiply the pi out, you could just multiply by 3.14. What you would have to do is just read the directions to make sure that, you know, you're following the directions. Like, is it saying you leave it in terms of pi or put it as a decimal? I'm just going to leave it as in terms of pi. Because I know that you can just multiply by 3.14. All right, I have one more example of finding the prism. I thought I would, volume, I thought I would do one that's not a beautiful one. We want to find the volume of the prism, and notice that this is a hexagonal prism. So we have to remember, how do you find the area of a hexagon, right? So let's take a quick second and review that. Remember, and maybe what we can do is do that over here. The area of a hexagon, remember, was 1/2 the apothem times the perimeter. So if I redrew the hexagon, right, this is your length of your side, and then you had to figure out the apothem, which we'll call here. So remember, what you do is you find your central angle by taking 360 divided by 6, and that's going to give me 60, and then you cut that in half to give you this guy right here. That's a 30. So if I draw it a little bit bigger so we could see it, this is 30 degrees, there's my 90-degree angle, this is my apothem, this is half of 3.5, which is 1.75, and now I would need to figure out the apothem. It would be real simple just to do the 30, 60, 90 right triangle, or you could use trig. It looks like here you would have to use the tangent, right, because the tangent of 30 is the opposite over the adjacent. And remember, whenever your variable's in the denominator, you divide. So we would take, so here's what we're going to calculate. We're going to take 1.75 divided by the tangent of 30. 1.75 divided by, and then I have to hit 30 tangent, and then I get about 3.03. And so that would be my oh, I'm way down here on the other side, but that would be my apothem. And now I would need to know the perimeter. Remember, the perimeter is there's 6 sides at 3.5 each, right? So the area of the base, capital B, is going to be 1/2 the apothem times the perimeter, which is 6 sides at 3.5 each, right? So now I'll just calculate that out. 3.03 times 6 times 3.5, and then just divide that by 2, and I get about 31.8. I guess we can just leave it at 31.8. So there would be the area of my base, and then the height of the prism is just 10. So the volume is going to be the area of the base times the height, which is just going to be 318, and that would be in terms of inches cubed. So I mean, really, it doesn't get any more difficult than that. I mean, and it hopefully makes sense. That's why we did that section on finding the area of a polygon, was so that we could do this, find the area, or the surface area, or the volume of a prism. The last thing we're going to do is pretty much, it's nothing real new. It's just a principle that I've seen here and there throughout, sprinkled on ACT questions, and oh, I don't know. I've just seen it around. It's nothing real new. All it's stating is that if you have 2 solids, and they don't even have to be the same kind of the solid, they don't even have to be, when I say that, they don't have to have the same bases, but if they have the same cross-sectional area and the same height, then they're going to have the same volume. So as an example, like here we have a cylinder with the area cross-section is a circle. So you would find the area of the circle, right? And then here we have a rectangular prism. Find the area of that rectangle there. If those two match and they're both the same height, then they're going to have the same volume. Have you ever noticed that some companies use circular packaging, some use rectangular prism packaging, right? Some use different types of packaging, and so that all comes down to just how much the package can hold, and so that's just called Cavalieri's principle. So if I wanted to find the volume, it says use Cavalieri's principle, but I don't really have anything to compare it to. But you're just finding the volume. Well, remember, of a rectangular prism, it's going to be the area of the base times the height. And this is an oblique prism. It's kind of on its side, but it's still the same thing. Think about it this way. If it was sitting up this way and I tilt it this way, is that going to change how much it's going to hold just by tilting it? Not really, right? It's going to be the same. But anyway, so the area of the base is going to be 11 times 6, and the height is 14. So in this case, we don't even need the 7. That's nothing. That doesn't tell us anything. That's just how much it's tilted over. So you're still finding the area the same way. So it would be 11 times 6 times 14. And we get 924. I'm going to just double check that. Make sure it sounds good. Yep, 924. And that would be in terms of meters cubed. Okay, guys. I have one last example for us, and then I'll do a couple off the homework. You want to determine the number of yards concrete. How many number of yards of concrete will you need to pave a driveway that is 30 feet long, 18 feet wide, and 4 inches thick? All right, so let me just try drawing a diagram here. So here's a driveway. And of course, this is not going to be drawn to scale, obviously, but pretend that you have a driveway here that we want to pave. Okay, I should have made it way longer, but oh well. And so what they're saying is that it's going to be, so think about a driveway. Let's just look at it from the top. Okay, so if you think about your car, and here's your car, you're driving into the driveway. They're telling you that the length is going to be 30. The width is going to be 18. Now the cement itself, which is going to be the height, is going to be 4. Okay, so let's pretend that we've got 30, and this is just, we're looking at it at a weird angle. Now, the one thing you need to look at carefully is that the length is in 30 feet, the height is in 18 feet, but and I meant to, that is your width, the height is in inches. What you have to do in order to calculate this out is you need to get all of your, oops, that was inches. You need to get all of your units matching. So you would say, okay, what's easier, to change everything to feet, to change everything to inches? I mean, it's up to you. I'm guessing that it would probably be easier to change everything to feet since we've already got feet here. So there's 12 inches in 1 foot, right? So if I wanted to, I could change this to 30 times 12. That's a big number. 18 times 12, that's a big number. Or I could just take this one and say, okay, well, 12 inches is 1 foot, so how many feet is 4 inches? And that would just simply divide, right? And I get 1/3 of a foot, right? So instead of saying 30 by 18 times 4, I'm going to say 30 times 18 times 1/3 of a foot. And now I'm ready to calculate. Remember, the volume of a rectangular prism is length times width times height, right? Or the area of the base times the height is the same thing. So the volume would be 30 times 18 times 1/3. And so that's easy. The 3 cancels the 18 and makes that a 6, right? And 30 times 6 is 180, and that would be in terms of feet cubed. So that's how much, that's the number. Oh shoot, they asked us for yards. This is how many feet there are. I just noticed that the question asks us for how many yards. Well, that's not going to be that bad. We already found, we can come back up here actually. There are 3 feet in 1 yard. This answer that I just found is actually in feet. So what you could do is we could say, okay, well 30 feet is the same thing, divide by 3, because there's 3 feet in a yard, so that's equivalent of 10 yards, right? And here, if I take 18 feet, remember there's 3 feet in 1 yard, so you're going to divide 18 by 3, you're going to get 6 yards. And 1/3 divided by 3, think about that, 1/3 divided by 3 is the same as 1/3 times 1/3, which is 1/9. And go back and do it again. So we would have 10 times 6 times 1/9, which is going to be 60 over 9, which is approximately, I know it's going to be a decimal, of 6.67, and that would be in terms of yards cubed. Okay, so yes, I'm sorry, I did it in feet. I didn't really read the directions carefully, but then the question says how many yards of concrete. So about 6.67 yards. There's other ways you could convert that. We could have just done it from here, but I thought, well, let's just stick with the formula of the area. All right, or volume, excuse me. I think we're done with the notes. I think I just wanted to go through a couple things on the homework, so let's take a look at that, and then we'll call it a day. So here we want to find the volume. Pretty easy. You're just finding the volume time, the area of the base times the height, the area of the base times the height. Notice that this kind of triangle, notice you've got your little right angle down there, so this is real similar to the problem that we did on the notes. You even have a hexagon there. Here are 3 problems where you are finding the volume of a cylinder. And here you are solving for one piece of information. So why don't I do one of those for you? I guess how about look at number 12, because here you're looking for something different besides what is the volume. You're actually told the volume. It says solve the variable using the given measurements. The prism and cylinder are right. So the variable here is the height of the prism. So remember, the height is the distance between the 2 bases. So the volume is the area of the base times the height. Your h is going to be x. You know your volume is going to be 455. So notice that on this triangle, you are told the base and you are told the height, right? And that's as far as the area of just a triangle in general, right? So how do you find the area of a triangle in general? Well, it's 1/2 base times height. So it's going to be 1/2 of 10 times 14, which is going to be 1/2 of 140, which is going to be 70. So the area of your base right here, this guy right here, is 70. So the volume is equal to the area of the base times the height. So you're going to divide by 70, and boom, there's going to be your answer for x. So 455 divided by 70, and I get about 6.5. And that would be in terms of inches. And there you have it. So it's kind of the same thing where you're working backwards to figure out a variable. All right, guys, that's it on 12.4.